I'm Sadil Kumar from Rajiv Gandhi College of Engineering and Technology. Software testing. What is software testing? Once the source code has been generated, the software must be tested to uncover as many errors as possible before delivery to the customer. Your goal is to design a series of test cases that have been to finding errors, likelihood of finding errors. But the question is how to do. That's where the software testing techniques enter into the picture. Software testing methods. We have two type of testing methods. One is white box testing methods, another one is black box methods. What is black box testing? Black box testing fully focusing on input and output condition of the software. The white box testing fully focusing on internal structure of the software. White box testing technique. The white box testing, sometimes called glass box testing. Using the white box testing methods, the software engineer can derive the test cases that guarantee all the independent paths within a model have been exercised at least once, exercise all logical decisions on their true and false sides, execute all loops at their boundaries, exercise internal data structure to ensure their validity. Basis path testing. Basis path testing is a white box testing technique. Using the basis path testing technique, we have to find different execution path in the program or software or applications or models. Each path guaranteed to execute every statement in the program at least one time during the testing. That is the aim of basis path testing. So how to do that? Before going to testing using the basis path testing technique, your program must be represented by the way of using flow graph notation. What is flow graph notation means is a simple notation for representation of control flow called flow graph. Our program is made up of different control structures, logical control flow. These flows shows the execution path of the software. We have some general flow graph notation. What are the notations we are having is, the first one is called sequence, the second one is called if condition, third one is called while loop, until, and then case structure. All these notations can be represented in the form of flow graph. To know more about basis path testing technique, first we should understand, by the way of using the following two figures, we can easily understand what is called basis path testing technique. To illustrate the use of flow graph, we consider the flow chart that is called A. Flow chart 1 shows about the flow chart about the one particular model. The second one is called flow graph. Corresponding flow graph of flow chart 1. Within this flow graph, the circle represents node and the edges represents links. Each circle called flow graph node represent one or more procedural statements. A sequence of process boxes and decision diamond can be mapped into single node. The arrows in the flow graph called edges or links to represent the flow of control. An edge must terminate at a node even if the node does not represent any procedural statements. Regions are area bounded by edges and nodes are called regions. When counting the regions, we include area outside of the graph as another region. Predicate node. Each node that contains condition is called predicate node, is characterized by two or more edges emerging from it. Consider this notation. the node A and B become a predicate node because of these two have the decision program that introduce at least one new set of processing statements or new condition. Independent path must move along at least one edge that has not been traversed before. These are the preconditions for independent path. Like consider this diagram. We are having four different paths. The path 1 can start from edge 1 and end with 11. This is the first flow graph, first independent path. Path 2 is in 1, 2, 3, 4, 5, 10, 1, 11. Likewise path 3 and path 4. So in this flow graph we find four different kind of independent path. These four independent paths can ensure that at least one time all the statements in the program can be executed. You may be considering another path. This is not a new path because of this is the combination of already invented path, and also this does not introduce any new edges. So I already told you what is called node is. Node is nothing but one or more procedural statements in the program. And while we are considering the regions, in this diagram we have four different kind of regions. One is region 1, region 2 and region 3. While we are counting the regions, we have to consider outside of the flow graph as one region. So we have another region is called region 4. Once we have discovered all this, we have four different kind of paths. Paths 1, 2, 3 and 4 constitute the basis set of flow graph in the previously mentioned figure. If the test can be designed to force the execution of this path, every statement in the program will have been guaranteed to be executed at least one time. Every condition will have been executed on this true and false sides. Cyclomatic complexity. How do we know how many paths we have to look for? That is a question. To answer these questions, cyclomatic complexity provides the answer for these questions. Cyclomatic complexity is a software metric. When used in the context of the basis path testing method, the value computed for cyclomatic complexity defines the number of independent paths in the basis set of program. Provide us the upper bound for the number of tests that must be conducted to ensure that all the statements have been executed at least once. These are the three formulas we are having to compute the cyclomatic complexity value. The first one is number of regions correspond to the cyclomatic complexity. The second one is the cyclomatic complexity V of G for the flow graph. G is defined as V of G is equal to E minus N plus 2. Here E is nothing but edges and N is nothing but number of nodes in the flow graph. Third one is cyclomatic complexity V of G for a flow graph. G is also defined as V of G is equal to P plus 1, where P is nothing but number of predicate nodes contained in the flow graph. So based on these three formulas, we can calculate cyclomatic complexity value for this diagram. So in this diagram, based on the first formula, number of regions, we have four regions, region 1, 2, 3, 4. So the cyclomatic complexity of this graph is 4. And second one is number of edges minus number of nodes. In this diagram we are having 9 nodes and 11 edges. So 11 minus 2 plus 2 equal to 4. So 4 independent path. And the predicate node is 3 plus 1 equal to 4. In this flow graph we are having 3 predicate nodes, 1, 2 and 3. 3 plus 1, 4. 4 region. So 4 predicate nodes. So we have to find 4 independent path. Once you are executed all this path, we can guarantee that all the statements have been executed at least once. Next one is black box testing.